Define a person's family IQ score as 0.5 times IQ score plus 0.5 times relatives IQ score, where relatives IQ score is the average IQ score of that person's parents, full siblings, and children. Given a data set of people and their IQ scores, determine who has the highest family IQ score. Here's the solution I came up with. It's kind of long, but I think the code's longer than the actual logic, so let's go ahead and break it down. Here's the strategy. I want to build a dataset of moms with ID, mom IQ, a dataset of dads like ID, dad IQ, a dataset of siblings like ID, sibling IQ, and a dataset of children like ID, child IQ. And then I want to concatenate those into one tall data frame of relatives that has every ID, relative IQ. From there, I can calculate the average relative IQs, pipe those back into the person's data frame, and calculate each person's family IQ score. So as a first step, let's build that moms table, which has ID, mom IQ, and only rows where mom ID and mom IQ exist. For that, I can do pd.merge, setting left equals person's ID mom ID, right equals person's ID IQ, how equals inner, left on equals mom ID, right on equals ID, and suffixes equals the list, empty quotes, underscore relative. Note that I'm inner joining the person's data frame to itself, but in the left table I join on mom ID, and in the right table I join on ID. Also, the output isn't exactly what we said we wanted, but it has more or less the same meaning. Then we do nearly the same thing to build a table of dads. To get full siblings, we have to join them both mom ID and dad ID. We also have to drop rows where mom ID or dad ID is NA. And we have to exclude matches where ID from the left table matches ID from the right table, because you can't be a sibling of yourself. And then for children, we concatenate the children of fathers and the children of mothers into a single data frame. Notice the column renaming that happens, where dad ID becomes ID, and ID becomes ID underscore relative. Now we can combine all the relatives into a single data frame. And then group the data by ID, measuring the average IQ of each person's relatives. Now we need to get the average relative IQs into the person's data frame, which we can do with some simple index alignment. We'll start by setting the index of persons to be ID, then we just set average rel IQ equal to average relative IQs. And then we can calculate each person's family IQ score. Lastly, we identify the person with the highest family IQ score using index max, and the winner is person 83.